I'll be talking about OpenRISC. I think today not so many people have been talking about OpenRISC, more RISC-V and other platforms, but I think this is still a great platform. It has a good tool chain and has a pretty well-written set of cores. And I'm going to give an update. So I'm Stafford. I'm basically a hobbyist. I'm not as professional as all of you guys working in the industry. I work as a software engineer, and I studied FPGAs, and I really liked it. And I knew I could do it for the last 10 years, but I never really got back into it. But last year, I started off with a project, and I like analog electronics, so I put together and I like music and recording, so I put together a microphone preamp. This is with a very basic LM741 op amp going into the FPGA, which this is the DO Nano. I think most people can probably recognize it. It has an onboard analog to digital converter, and I got that routed into the FPGA itself, routed back out to a digital analog converter, and those are both using the SPI interfaces. I'll stop right there, and this is last year, and I did it all by hand, but if anyone wants to ask any questions, I'll leave spots for that, because this presentation might go pretty fast otherwise. Yeah, so this was the project, and I wrote everything by hand, so you can see, like, the DO Nano has some buttons, and I've made a little push button interface, so you can click a button, and you have double click, and I think it already has debouncing built into it, but if you want more than 2 functions, you might want to have double click or triple click. I built those in. The analog to digital converter is a SPI interface for the FPGA, so the ADC is outside of the board. Microphone inputs come in, and I wrote a SPI interface. And then I have a little digital recorder state machine that acts kind of like a DMA controller, reading from the microphone and then writing into the DRAM. And I tried to create 2 clock cycles to learn about the cross clock domain. And so I have a FIFO in there with a dual clock FIFO that I also wrote. And yeah, so if you click the button, it would record reading from the analog to digital converter, writing into the SDRAM. SDRAM controller I wrote by myself as well, and I spent many hours and nights sitting with the AC data sheet, and I found out that actually most DRAM is actually all the same. The clock, the timing diagrams are the same, so it was really good to learn that because you couldn't really find anywhere else online that explains how it works. I think it's something people either just use a core or maybe they learn it on the job. But I figured that out, and it's running at 100 megahertz. Probably not as well verified as some cores, but it works. And then it would write back out to the DAC. And I've played with also pulse width modulation and things like that. But I bought a chip that can do digital analog conversion. And that's where I was in 2015, and I thought, I need to be able to probably not write my own cores, use something more professional, use something that can be shared. And also I was doing this it's all in the Quartus platform, and sharing code in Quartus means copying and pasting your core from one project to the other, and that just didn't seem to work very well. Any questions before I go on? No? Okay. Yeah, so the next step is so I wanted to find shareable cores, a better development life cycle, because I'm from software and I know that you have modules like libraries that you can just bring in, and you have shared objects that can be linked together. I wanted to kind of have that same type of thing with FPGAs, and it didn't seem available. And also, after I wrote that project, I didn't really think I could write something much bigger by myself. So I thought, oh, maybe if I can get this DO Nano to run Linux, is that possible? So I searched on the internet, and what came up was opencores.org. which had a bunch of documentation, but like how to run Linux, there were probably 3 different tutorials on how to run Linux, and how to build toolchains for the OpenRISC processor. It was quite, it was a bit confusing at first, and you get lost. So later on, I found the OpenRISC channel, and I started talking to people, and it actually, I found that opencores.org is not the place to go. Maybe people searching on the internet for open cores right now will find that, but hopefully through this presentation and this year we'll talk about what are the right places to go, and we need to make these other websites like OpenRISC.io or the FreeCores or the FalSi Foundation more or higher ranked in Google or whatever search engine you use, so that if you're searching for running Linux on a FPGA, you'll get to the right places rather than these old OpenCores websites. OpenCores has SVN hosting that mostly we've moved to GitHub now. There's a media wiki that we either use GitHub pages a bit now, and there's a forum, which now we are trying to do mainly on the mailing list or on IRC. But if you go to OpenRISC.io, I think I even talked to Jeremy earlier. He hadn't even heard of it until just last week. OpenRISC.io is trying to be the new home for the OpenRISC processor and platform, but it's a work in progress. The download section is blank, so I would expect if you go there, you can download releases of GCC or releases for whatever software we have, but it's blank. The tutorial section, it has quite a few entries, but there's some tutorial work that we've been working on how to build the system or how to debug OpenRISC processor or how to do other things, and that is not linked there. And then also there's the OpenRISC specification itself, so the ISA for OpenRISC and the ABIs, all the specification is still on OpenCores, and it would be good to get a new home for that on OpenRISC. So we're working on that, and hopefully by next year it will be a better situation. The other thing that we have that many people don't know about is the OpenCores SVN hosting. It hosted a lot of cores, and a lot of it has been mirrored onto freecores.github.io. It works pretty well, and if you want to fork cores, I'd suggest using this one instead of the OpenCores hosting right now. Any questions? Okay, one question. Dan?
So I've looked at FreeCores. In particular, I've looked at it as a potential alternative to OpenCores. One of the things that OpenCores has, which FreeCores does not yet have, which I would highly like to spend a moment to recommend to the whoever's maintaining FreeCores, is a searchable way of working through the database of cores, like OpenCores has its project list, where you can then go and search projects.
Right.
I understand that project list is, well, I'd love to get some things OpenCores certified, and nobody answers my mail when I come and talk to them.
Right.
So that would be perhaps we can have that discussion here over this weekend as to what we want to be able to search cores by. I think one fascinating way to do it would be to add some metadata to FuseSock core files, and then have FreeCores allow you to search through a FuseSock or a set of FuseSock core files and see from that, is it what you're looking for or not?
Yeah. Yeah, I think that makes sense. We did have a discussion on that on IRC.
So actually, that's like the presentation tomorrow. FreeCores was like, it was Christian, right?
Yeah.
Just because the SVN was always failing. Like everybody knows, like OpenCores SVN is the most unstable SVN in the world. And so he mirrored all SVNs to GitHub and named it FreeCourse. But tomorrow we will present LibreCourse, which exactly is this. It's a replacement for OpenCourse, which is a searchable database of metadata. It's not hosting. It's just like it uses actually also some kind of like README file parser to extract metadata. You can assign tags and so on. This is the idea. But
all right, yeah, that sounds good. The metadata, the free course metadata, it does provide a searchable table if you go there, but that's all pulled from GitHub itself. So it says the author is from GitHub author, the language is from GitHub's AI that figures out the language somehow. It's not that extensive. So why is it that confusing? I'll give a brief history. Maybe these dates are not perfect, but OpenRISC, the OR 1000 spec was started, and they were writing GCC for it back in 2000. I think it started in 1999, but I think it was publicly announced in 2000 by a few people. And around 2001, these same people, I don't want to mention names, but they started up OpenCores, but it's always been owned by a corporation. Maybe it was it Flextronics originally or something like that. And in 2005, the founders went to create another company, and they left OpenCores unmaintained, pretty much. In 2007, it changed hands to another company, and this company, as of very recently, I believe, is now bankrupt. So that's why for the last 2 weeks, actually 2 weeks ago, for a week or so, OpenCores was down and inaccessible, completely not available anymore. And this was anticipated, and that's why last year the FOSSI was created, which people talked about earlier. And out of that, there's LibreCores, there's the freecores.github.io, and there's OpenRISC that have all been created. Now, the goal is, like, if I go to Google and search for, reusable cores or running Linux on my FPGA, I shouldn't get to OpenCores, which happens right now. We should get to these other websites, especially for other things like licenses. If I want to look up Silicon licenses, I don't want open source licenses. It shouldn't redirect us to open hardware licenses because it's a little different. So we're trying to make this presence better known. And yeah, so other than that, another thing I found when I started off, so I started off, I built the kernel, I got it running, but after trying to modify software, I was making patches, I was sending patches in for the OR1K-source because that's what was referred to on the OpenCores site. But it turned out that has been, we're trying to get away from that. That's the old repo that everything was stored in there. The GCC, binutils, GDB, and newlib, and a few other things were all stored in the one repo. And basically, this is an old repo, and we shouldn't use it. The other repos, which I'm going to go over now, are now tracking upstream GCC or upstream binutils, GDB, and newlib. And so they're much easier to patch and much easier to send our patches back upstream. And the one thing that's missing, though, is there's a deja GNU, which is the test utils. There's a board configuration files for OpenRISC itself so that we can do basically unit tests. So a lot of the GNU packages here, they have unit tests where you say make check, I think, and it will run a set of tests to make sure your binaries are creating valid code. It can run it on a simulator. That config is all there, but it needs a home. So if anybody has a suggestion to get rid of this OR1K source completely, then it's all on GitHub. So the OpenRISC/OR1K source is, it's not on SVN. It's all on GitHub now. Yeah, we want to delete it, but it still has some, yes, in the back. All right.
It's a horrible mistake, OR1K source, and unfortunately I'm responsible for it. It's to do with the way GNU expects to build toolchains in a unified directory, even though it's made of separate projects. And the mistake we made was to try and recreate the whole unified directory. It doesn't work. What you really want is you want a separate directory, which is a toolchain directory, which just has the scripts that combines and pulls in the other things. And that's fairly well established, and we did set that up when we did the commercially tested version of the toolchain for NASA a few years ago. But we can take that offline, and I can share that with you, which will probably speed things up for you.
Yeah, and I believe you also created the DJGNU configs, so we can talk about that. Thanks. That was Jeremy. So next is, okay, so how we've taken all these, the tool chain pieces out, and we're trying to track upstream, but how are we doing now? One of the main things is before GCC is compiled, we need bin utils. It's doing pretty well. We've released 7.11. When did we release it? I think earlier this year. Upstream is now at 7.12, and what is it? Native simulation support. Yeah, so there's been a bit of work on that. One thing I did this year was run the unit test. So we wanted to make it go up. We wanted to make a lot of our changes. We have about 40 patches that are pending, and we wanted to take it upstream. But to take it upstream, we need to show that our tests run and that we're working, that the system's working pretty well. So I spent a lot of time this year with Olaf and a few other people working through the GDB tests, actually. The GDB tests will test bin utils and GCC and everything, actually, all together. And it uncovered quite a few bugs that we fixed. And also, one of the things that the DJGNU test works on is, okay, when it's running, it doesn't have an actual OpenRISC platform to run on, so it doesn't run the test running on FPGA, it will run it on a simulator. And there was a simulator that we had in GDB, but it was based on the OR1K sim, which is a separate binary. Maybe people have seen it, but it's not QEMU or something else. It's a purpose written simulator for the OpenRISC. But the way that this old simulator worked is GDB would start up, and it had a light library that would call out to the other binary to do the simulation. But we knew that that really wouldn't work with upstreaming the simulation and test code to GDB. So there had been some work on a native supported binary, a native supported simulator that I got working, and it was quite interesting. And so now, basically, I believe it's ready to go upstream. I just need to, yeah. So the simulator, I think I'll have a slide. Yeah, so the simulator is based on CGen. So within GDB, they have a generic language for defining a system. And it's CGen, which is actually some scheme code that defines how everything works. And so scheme is Lisp, basically, which they like a lot in their GNU toolchains. But it allows, it defines the whole architecture, and then you have to define some system level code, so you define the architecture, but then how to actually fetch instructions and execute them and what happens. You have to implement in C code, so you have the specification, and then you have the runtime, which is two different parts. And so once you have that running, when you run GDB, so this is an example program we have. So we have some data, we have some static data or some data that's stored in memory. We have some function, and we have a main program where you have maybe some data on a stack, and then you can pass data to foo, and it will just return the data. I don't do anything with the data. But with a simulator, you can compile it. This is using the newlib toolchain, so we pass OR1K-ELF GCC, and we compile our test program. And then running GDB, I would say just GDB test, and the simulator I would start up by running target sim. And that will load up this simulator as the target that we're going to run the code on. And then you say load, which will load up the binary, and it will get it into the simulator's memory. If I can set a breakpoint on main, and when I run it, it will stop right where main is started, and I can debug it. Now this is running on the simulator, and any questions?
This is Julius. So that CGen port, was that already in the toolchain?
It was already there, but it wasn't used in GDB. It had been...
I have vague recollections of playing with that, but
Germany.
Okay, but what is the system? Because the whole point of OR1K sim was, you could define this size memory and these peripherals and whatnot, and
Yeah.
it was
It has no MMU. It has no peripherals. It's only
just the CPU and memory.
Just the CPU and memory, and that's
Cool.
it.
Okay.
CGen's just an instruction set simulator, that's all it is. AllSim was originally conceived as the golden reference for the architecture. And it's quite useful to have that to test against. CGen is used to generate the assembler, the disassembler,
Right.
and the simulator. And it's what was there originally. That's how the first simulator and how the first disassembler and assembler were done. The slight danger with CGen is you're testing against yourself, so it is a bit self-referential. It doesn't matter so much for the compiler, it can affect you when you're testing the assembler, which is why you need alternative targets. But there's no problem. This works just as well testing against a remote FPGA target or indeed against the Verilator model. And when we did the 4.5.1 GCC, we actually regression tested against Verilog simulations.
Yeah.
It's good to know it's been reinstated though, so that's cool. Cool to see.
Yeah. And one thing is, with this, like the OR1K sim, it still allows it has a GDB server in it. So if we want to run our tests, instead of saying target sim, we can say target remote, and we can connect to an actual FPGA, or we can connect to the OR1K sim. So this is just to allow us to kind of get upstream. And it's an easy alternative, so you don't want to have to set up an extra process that can run the code. The interesting thing here is, one thing that the simulator does is it allows for stack frame creation, which is something that it gets you really involved with the ABI of OpenRISC and some of the quirks in the ABI. So the test case, they do a lot of test case about passing in large structs through function calls, or passing in parameters to var args. I don't know the word for it, but when you can have a ... at the end of your function call, and the OpenRISC ABI around passing in those var args is quite convoluted. It's a lot different than other systems. So we'll talk about that a little bit later. But basically, what happens here is if I run it, it will stop when it starts, and I can call the function and get the output. And when I call this function, it actually will build up a stack frame in GDB itself and call the function on the simulator and then return the results. So while my program is stopped, it will use the memory and create another stack frame on the target. You can do this on the Open OCD or on the OR1K sim as well, but that was something that needed some work to get a lot of tests to pass. Did I skip a slide? Yeah, so this was just about showing how we did in terms of our progress on testing. So when you run it, you export déjà GNU, and then you point to this location, which we need to find another place to host, but that's in the OR1K source directory boards, and there's a simulation set up. And when you run make check in your GDB directory, it will run all the tests. And before basically, number of expected passes, that's how many tests it could actually run. So this takes quite some time to run, actually, the 18,000 tests. Before we started, it actually was around 14,000, but by the changes we made, it allowed more tests to be executed. In terms of expected failures, there's unexpected failures is how many fails we have. So there are still things that are broken, and I don't think we'll get to 0. It's a lot more work, yeah?
So was that against the CGen model or the OR1K sim?
This is against the CGen one.
Okay, cool.
Yeah, there's a different one. There's that OR1K ELF. I think there's an OR1K sim, and then there's a sim one. But yeah, this was against the sim.
CGen, yeah.
And then, yeah, so we got a few better. We're testing more, and we're getting less failures than before. And a lot of the other ones that were failing are due to things like IMMAP is missing. So we don't run on an operating system. So I didn't want to try to make everything run, make the sim run Linux itself and run the whole GDB on an operating system. But maybe later, or other people can help out. And yeah, so that is the progress we're making. And I think this is ready to go upstream. This was just the dummy called some of the difficult things was structs and unions need to be passed as pointers. And this gets a bit complicated because if we're running a simulator and you want to pass structs and pointers when you do this you want to pass structs and unions when you do this kind of dummy call, it has to create a stack. And where's your pointer going to point if your data is not in the memory yet? You have to copy, if you make a struct in the debugger and you want to pass that fabricated struct to the function call, you have to then copy that struct, but not onto the stack, somewhere else in memory, and then point to it. So it's kind of, was a bit of I put some hacks in there, and I asked people to review it, but no one. I put a hack. I just copy it to the, so you have a stack frame, and you put all your arguments at like the top of the stack frame, and I said, okay, within the stack frame, if I need to pass in anything, I'm going to just put it at the bottom of the stack frame and then point to that, and it could, like they could collide and I would have a big issue, but it's just for debugging, so I don't think it matters. But if people have a better way to do that, then let me know. Next was the libc. New lib is the one that we have our own fork for, and there's also a musl and there's the micro C lib, or I don't know what it's called, but those are pretty much, the upstream is fine, and I'm not going to talk about them. But for new lib, we did a release in March of this year for 2.3. Stefan did that, and since then, upstream has not really progressed. So new lib upstream is 2.4, which we have in GitHub, but we haven't created an official release for that yet. But we have patches, about 20 patches that need to be sent upstream. So again, something that we're working on. I need to get my copyright signed over to the FSF to be able to do that. So I haven't had a chance to work on that, but yeah, that's the current progress on that. Any questions about libc? No? Okay. And then the next is, the interesting one is GCC itself. Did you have a question? GCC itself is, we have 5.3 released earlier this year. 5.4, I created a release for that last week or so because I was trying to build a Linux musl toolchain and it wasn't working. So I found that some of the errors it was throwing, I looked for patches for it and I found them in the 5.4 release from upstream GCC. I just pulled them in and everything worked fine. So we're tracking the 5 release pretty well, but upstream already, GCC, they have a release 6, which I tried to merge in, and there are a lot of conflicts in GCC 6, and GCC 7 is also in development on GCC. And the other thing is, everything is pending upstream. We still cannot send the GCC patches upstream because a lot of them are based on works, or they're done by some people who have not signed over their license or their copyright to the FSF, the Free Software Foundation, and they cannot because of some company board conflict. And so we're pretty much stuck unless we either rewrite GCC from scratch or choose another compiler, which maybe, yeah? Yes, only one. We've contacted them.
But he's not playing ball.
No.
Do you have a measure of how much of his stuff is still left in there? Because when we did that 4.5.1, we rewrote an awful lot. Because you've still got the CVS repositories,
Yeah.
you can go back and compare, because I suspect there's not much left of his original code in there.
Yeah.
And the solution is to toss it out and
Yeah.
rewrite it. And if it may not be as big a job as we think. I mean, you've done a fantastic job to round up everyone else.
Yeah, we have rounded up everyone except for one. And I think this was a topic in a previous year.
Yeah.
But it turned out when we talked to the Free Software Foundation, they said that even though we've thrown out the code, it's based on a derived work, and we're not allowed to use that. So, I'm not sure if we can change that argument.
It's derived so long as you can show there's a chain of derivation. Right. If there is no chain of derivation,
right,
then it is no longer a derived work.
Yeah.
If you've taken out all his contributions and replaced it by stuff that is not a derivative of his, and all the stuff we put in there was certainly rewritten from scratch because we replaced stuff that was nonsense, okay, then you may actually find there's a perfectly valid chain that just leaves him out.
Okay. Yeah, that's something I've been meaning to do, and I did look into the repository. Do you think it would be in that OR1K source or another repository? Because I was looking in the OR1K source and I could not find the history.
So it's because it goes back to the CV. You'll have to go back to the CVS repository,
yeah.
Okay, and look at the GCC there,
okay.
And then compare. It's probably the .md file, the machine description,
Yeah,
and a little bit of the source support code. But I'm pretty certain Jörn Renneker rewrote almost all of that.
All right, thank you. I'll have another look. But if we can do that, then we can get this upstream. But there's a lot of work to get the other versions updated as well. And even, I think if we start working on the 6 or 7, we might find that having to rewrite even more of it would be required, and that would get us farther away. Thank you. So the other thing, that was the tool chain, and Linux is something that I've been having an interest from in the beginning, and one of the reasons I've been working on all the tool chains is to get Linux working a little better. And Linux has been without a maintainer since February of 2012. Jonas, who I'm not sure if he's here, but if he is, then let me know. He has done a good job on the kernel, but without a maintainer, we can't get more code upstream. And to get code upstream, we need one of our maintainers in the group needs to be able to have a PGP key signed by the Linux kernel community. And we haven't been able to get that yet. Maybe we will, but so far, I've been working on patches and trying to make a conversation on the Linux kernel mailing list about, I've sent patches and then I said, we need help getting it upstreamed. There's been some help on that, but nothing that has really, that has made much progress. But I think if we just keep sending patches and making sure the patches are perfect, then one of these days people are going to help us out. A few things I've worked on here are this year I did start working on some of the to-do lists on the Linux kernel. One is MemCopy. So the current MemCopy, there's a default implementation in the kernel that just does byte copies. And for a word-based, 32-base 32-bit based word system, that's not very efficient. So I went through and I wrote in C. I think there's been a memset implementation that's also been added recently. That's written all in assembly, which is nice. But I chose C because I think it's a little easier to maintain. And I wrote multiple implementations and then compared their performance. So as we can see, there's the byte-based copy. To be able to, while it's booting the system, it does an average of 7,600 byte copies. So that's how many instruction cycles are used inside of the MemCopy routine. There's multiple ways you can optimize this, which was just something I was doing. So one is loop unrolls. So if you're copying, 1,000 bytes, a lot of the instructions are cost doing your loops. So your jump, am I at the end? Your check, and then your branch if you're not at the end. If you can unroll, meaning you say, okay, am I at the end? If not, then copy 8 bytes. So it'd be move, 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 not move, because there's, yeah, any?
So, what a wonderful topic here, MemCopy. I don't know if you noticed, I was marveling recently at the MemoryCopy that was within the Drystone code.
Yeah.
That was handed to me that looks very similar to a lot of the work you're looking at. Mm-hmm. When I then complained that it was hand optimized by somebody to use, I can't remember if it used loop unrolling, but it certainly used word copies. I think it might have done some loop unrolling as well. And I would love that optimized code. It was pointed out to me that I just needed to look closer at the newlib code.
Yeah, yes, there is optimized code in the GC or the libc libraries.
And so I guess I just wanted to comment on that and ask if you wanted to discuss any of the difference between the MemCopy you're putting together and the newlib code, which contains a lot of this, but certainly doesn't do any assembly optimization.
Yeah, no, I did look into those, and but the thing is, if you're running in the kernel doesn't use libc code, so you can copy code into it, but I didn't really want to do that. I wanted to rewrite it just for licensing reasons. And also in the kernel, every single architecture has their own, if they, like Neos or the ARM guys, they have their own, either written in assembly or in C, their own implementations which have assumptions about the hardware and architecture. But they didn't have some of the things that I went through, so that's why I rewrote my own. And so loop unrolls, as I was saying, instead of, I mean, maybe everybody knows that, but instead of doing a branch and not move, but because you don't do move in OpenRISC, but branch and move, you do a branch and then move, 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 and then you go back and that's loop unrolls. The other is to just do word copies, but the thing is, like if you're doing a word copy, if it's an unaligned move, so if you're moving from an offset that's not a word offset to another offset, you have to have some special logic to do realignment, and that causes actually a bit of, you have to do shifts and ORs to get your data back aligned. And it turned out that in the end, I mean, with the non-aligned copy is quite a bit more complex. The loop unrolling, it makes your code a little ugly. And then in the end, we chose to go with the word copies because it was a good balance between performance gain and complexity. It's not that complex. And we didn't have a lot of unaligned moves within the kernel. So we went with that, and the increases from the boot time on my Dio Nano was from 7 seconds to 5 seconds. And I think that was a pretty good gain of just changing one function. The other thing I did was, there's an old, inside the Linux kernel, the memory management has a few different subsystems, and there's an old one that's called bootmem, and I converted it to the new subsystem called memblock. I don't remember the details, so don't ask any questions. But yeah, so I've submitted quite a few patches for review, and Jonas, the old maintainer, has given lots of good feedback on it, but we can't get it committed until we get a PGP key signed. Yeah, so that's about it for my talk. But going back to the end is just about the project that I had started on. So what's my motivation? It's really just about learning more, about getting my FPGA skills back up to where they should be, and just contributing to the open source world. Now, I've always wanted to, once I saw all of these tools and all of the IP that's available, I wanted to use that to rebuild my original system and write Linux kernel drivers for my ADC chip, for example, and write one of the to-do items in the Linux code is making the DMA code more fleshed out. And so I was thinking to be able to create a DMA-based sound card that could read. You can say, read from the microphone and write to the DAC, and the DMA would then be able to do that. I didn't actually write that in here, but yeah, it's just my next step. But right now, I think the main thing is fixing up documentation and getting some of these codes upstreamed, which would really help out the community. That's about it. Any questions?
Oh, a couple of questions. All right.
Dan?
Sorry.
So I guess I haven't introduced myself at all. I am Dan Gisselquist, working for Gisselquist Technology. One of my questions, kind of a fun one, I'll hit on it a little bit tomorrow, but have you ever thought about using the DMA for a MemCopy?
You mean through libc, you would say?
I don't care if it's
Yeah.
through libc or anything else. The DMA is a
Yeah,
hardware optimized copy
yeah.
machine. If you could use it for a MemCopy, it's a whole lot faster than anything else you've got.
Yeah, but it would be,
Yes, sir.
yeah.
Yes.
You'd have to copy, it's like an asynchronous. You'd have to do the DMA lock and then wait for it to copy back, and then it could be done. Yeah, I haven't thought about that.
All right.
Sounds neat. One more question.
You mentioned in an earlier slide you're passing structures by reference, by address.
Yeah.
Did that cause, that's not the normal ABI, I don't think, so did that cause any bugs in the kernel operation or
well,
differences?
The GCC implementation does support that, so the assembly it generates works fine, but passing by address is not something that's pretty normal. Mostly, even if it's a large structure, they just copy that onto the stack when they're passing it. I think that's one of the quirks within this, but it didn't cause any bugs in the kernel. It does, actually, there's one bug in the API because it's the syscall APIs. So, and that's one of the patches that got rejected. But basically, when you call, I can't remember the syscall, it's some semaphore control, I think it's sem control. You pass in a union, and the kernel, it gets the call in, and the arguments it expects to be on register 3, 4, and 5, but it expects that the register is the actual union, but it's not. In OpenRISC, it's a pointer. So when it tries to debug the union, it doesn't work. So that is a problem, and we need to. The fix is there's a GCC keyword called transparent. So if you pass transparent, then it will treat unions, if they're just small enough to fit in a register, it will put the value in the register. But that would break all the Linux code. So you can't just put transparent on this public union. So my idea is to create a shim. So basically, when it calls into OpenRISC syscall, it will convert that pointer into the data and then call the actual Linux syscall. But yeah, it is a bug in user space to the Linux kernel, but not within the kernel. Does that make sense?
Yeah, I just wonder whether you can't trust the user to put ampersand in front of the structure if they want to pass it by reference.
Yeah, you could do that as well, but it's not. it's not binary. I think you'd have to change your header file because the actual spec says that you pass in a union, not a union pointer. The actual the API call in the header is you pass in a union, not a pointer. So you could change the API for OpenRISC and it would work, but that's changing the header file. Yeah, one more back there from Jeremy again.
Stafford, I slightly missed something. When you talked about GDB,
Yeah,
which version of GDB are you on at the moment?
we're on 7.11.
Okay, because the next release will go to being C++ only.
Oh, really?
And you have to have migrated your source across. At the moment, there's a sort of macro hidden way of hiding the C++.
Yeah.
I think for the next release, you need to migrate to that C++ world. It's not onerous, but it's something perhaps just to plan in to make sure that our GDB builds with C++.
Yeah, that's a good point. A lot of the upstream changes, if they change core APIs, it's a lot of work for us to keep. That's one reason we want it to be upstream, so we get notified when these things happen. But we haven't done that.
All right, I think that's it. Thanks very much, Stafford.
Thank you.
Appreciate your work, mate. Cheers.